will be run against the project which is created in the previous video. Let us start with the first command. DBT run is the first command which is used for running all models. In DBT context, it means executing all transformations. In our project case, 3 models got created successfully. Next command is dbt run -- select. This command aims to run a specific model. It is especially useful when the project is big, and running all models is not necessary. Next command is dbt clean, which is good for cleaning the target as well as dbt packages directory. You can simply apply this command using dbt clean. In our project context, this command will lead into the following output. If you check the project directory, target folder is deleted. DBT debug checks if DBT is set up correctly and the connection to the data warehouse is working, and the application of the command is like DBT debug. In case of our project, we will get the following output. When you run dbt compile, DBT generates compiled SQL files and stores them in the target directory inside your DBT project. You can apply dbt compile by writing it in a terminal. Here's how you can find and inspect the results through navigating to the target directory. Next command is dbt seed. Seed files in DBT are CSV files that are stored in the seeds directory within a DBT project. These files can be loaded into your data warehouse as tables using the dbt seed command. Why use seeds in DBT? Seeds are useful for reference data, storing small, static datasets like country codes, product categories, or mapping tables. Mock data for testing, creating sample data for development and testing. Lookup tables, providing predefined mappings, such as region codes to region names. Let us create a toy example of countrycodes.csv and run dbt seed command. Let us first create a countrycodes.csv under the seeds directory. Now let us fill the countrycodes.csv with some country to continent mapping. After running the dbt seed, the CSV file will be loaded as a table in the database. If we enter DuckDB command line using DuckDB dev.duckdb, we should be able to write a query like select start main.countrycodes limit 10 and see the results of the created table. If we modify the CSV file inside the seed directory, we can use dbt seed -- full refresh to refresh the table within the data warehouse. DBT provides an excellent way to generate and serve documentation for the models, sources, tests, and relationships. This helps data engineers and analysts understand the structure, dependencies, and metadata of a DBT project. The command dbt docs generate scans your DBT project and database, collects metadata about models, sources, tests, and relationships, and creates a catalog.json file under target folder, which contains structured documentation. After generating the docs, you can view them in a web browser using dbt docs serve. For our projects, we run dbt docs generate and dbt docs serve. We should be able to see the information about our tables in the browser. DBT snapshot is used to track historical changes in a table over time. It is useful for handling slowly changing dimensions. Whenever data updates in the source table, DBT keeps a record of the previous values. When you need to track changes in customer details, employee records, or product prices, when your data does not have built-in versioning, but you need historical tracking, let us create a weather snapshot.sql under the snapshots folder. As you can see, we define a snapshot weather_snapshot, and the config tracks the observation time. Whenever there is a change regarding the columns related to a specific site name, like change of site code or other changes, we will be able to see different versions. You will be able to query the created snapshot table using select star from snapshots weather_snapshot. If the value of a specific site changes, you should be able to see it under this table. DBT deps fetches and install all the external dependencies for the project. Let us create a packages.yml file and use dbt utils as a dependency. If we run dbt deps, we should be able to download dbt utils as a dependency. To show a realistic example of what it could be possible to do with an external dependency, let us create an example model named depsexample.sql. As you can see, we create this SQL file inside the intermediate folder, and we fetch all the columns except to specific columns. If we run dbt run -- select depsexample, we should be able to create such a model which uses dbtutils library. The next command is dbt run operation, which is for running a macro. In dbt, macros are reusable SQL functions that help you write cleaner, modular, and more efficient code. They work like functions in Python or stored procedures in SQL, allowing you to reduce repetition and automate common tasks. Writing macros have the benefit of avoiding code repetition and having more dynamic and flexible queries. Macros should be created under the macros folder in our DBT project. To demonstrate the utility of macros, let us see them in practice. Let us create a macro named row_count, which has the job of counting the number of rows in a table. This macro syntax is based on Jinja template. The following macro defines a function named row_count, which accepts two arguments of table_name and schema_name. The default value for the schema is main. It defines a query and in actually counting the number of records. We run the query using runQuery function and log the result output. If you have an open terminal and you run dbt run operation row_count and pass the table name, which is weather quality, you should be able to see the number of rows. Now you can see a summary of DBT commands which we went through this tutorial. Thank you very much for your attention. See you next time.